In order to verify that this function is one-to-one, I need to make sure that it passes the horizontal line test. I'm going to kind of skip over that part, but if you want to double check this for yourself, go ahead and graph this function. It's going to be the graph of a hyperbola, and you'll see that yes, in fact, it does pass the horizontal line test. Any horizontal line only intersects this graph once. I want to focus on this time finding the inverse. This one gets a little more complicated than the other inverse functions we've found, but the basics are still the same. I'm going to begin by switching x and y. So let's go ahead and rewrite this problem as x equals, and then 2y plus 1 over y minus 1. Now this technically is the inverse function, however we always like to be solved, we like our functions solved for y, so I'm going to need to do some rearranging on this one and some work. First thing I'm going to do is I'm going to rewrite this problem with x over 1, because as I see a proportion, this reminds me of cross multiplying, and in fact that's what I'm going to suggest we do to begin. So if I cross multiply, I'll start this way. 2y times 1 is just 2y plus 1, or 2y plus 1, sorry. And then when I cross multiply the other way, I just need to remember to distribute. So I've got x times x, y minus 1. I'm getting distracted as I look at my notes. When I distribute this, I end up with xy minus x. Okay, my next step, because this is definitely looking way more complicated than what I'm used to, my next step is going to be to get all of our y terms on one side. So I want to take this y term and move it over here. Well, I'll do it the same way I've always done, by adding or subtracting. In this case, I'll subtract that xy term. Now what I also want to do is get anything that does not have a y to the other side of the problem. So once again, I'll do what I've always done, and I'll subtract that 1. So I've just rearranged a couple terms. Here's my favorite part of the problem, and probably your favorite part too. Your favorite F word, we want to factor this, okay? So what I notice is that since my y's are all gathered together on one side, let's go ahead and just factor out the y. What's left behind then when I divide out a y is just 2 minus x. Okay, and then equal to negative x minus 1. Well, I've got y almost by itself now. To finish this, if it was y times a number, I would just divide by that number. Well, in this case, it's just y times the quantity 2 minus x, so guess what? I can divide both sides by 2 minus x. So what I'm left with then, finally, y is all by itself, and my new inverse function is negative x minus 1 in the numerator, and 2 minus x in the denominator. A couple things we might want to do with this. One thing, this sounds weird, but it's true. If every sign is exactly opposite on this side of the problem, it's the same answer. So not that I have to do this, but I'm noticing all these negatives in the problem, so I'm going to switch every single sign, and that actually means I have the same answer. I know it seems weird, but it's true. So I'm going to have a positive x, a positive 1, and then in the bottom I'm going to have a positive x and a negative 2, so I'm actually going to write it as positive x and minus 2. You don't have to do that, but because every sign is exactly opposite, it's really the same function. So if you want to do that, that's fine. Some ways you could kind of sort of check if you're right. This doesn't prove that you're right, but it's good evidence. You could graph both functions, graph your inverse function and graph the original function, and if you are right, what always happens, we talked about this in the other videos, is that your functions will always be symmetrical about the line y equals x. So these make some cool looking designs, and again, it doesn't prove it, but if you can tell they're definitely not symmetrical about that line, you'll know you probably did something wrong. And then the last thing I'll mention is, if you want to be really fancy, instead of saying y equals, maybe you want to do this whole inverse function notation. You can do that instead of y equals. It just means the inverse function of f.